Arrhenius concept of acids and bases. Now, according to this Arrhenius concept, acids are the species which gives H plus ions in aqueous medium. This is most important. Any species which gives H plus ions in aqueous medium is called Arrhenius acid. The best example about this is HCl, HNO3, H2SO4. This is called hydrochloric acid, nitric acid, sulfuric acid, chloric acid, perchloric acid, hydrobromic acid, HI, iodic acid, H3PO4, phosphoric acid. All these species in aqueous medium will give H plus ions. This can be explained by taking an example, like the moment you put this nitric acid in water, what we get is H plus ion aqueous and nitrate ion aqueous. So this release of H plus ion by nitric acid in water is called, in aqueous medium, is called Arrhenius acid. So therefore, these all can be categorized as Arrhenius acids. The advantage of this is that we are able to classify all these compounds which are having H plus ions, which releases H plus ions in the aqueous medium, as acids. Now, what are Arrhenius bases? Arrhenius bases, let us see. According to this concept, Arrhenius bases are the species which gives OH minus ions in aqueous medium. So what is the important condition, necessary condition for a species to be a Arrhenius base? Is that it must give OH minus ions in aqueous medium. And the example we can have is caustic soda, NaOH, sodium hydroxide, caustic potash, KOH, potassium hydroxide, cesium hydroxide, barium hydroxide, ammonium hydroxide, etc. So all these will give OH minus ions in water, in aqueous medium. This can be explained as when NaOH solid is added to water, what we get is Na plus aqueous and OH minus aqueous. So the release of this OH minus ions by this NaOH is giving us a proof that according to this Arrhenius definition, Arrhenius concept, we can classify all of these as a basis. The advantage of this term is that we were able to classify all these hydroxides, metal hydroxides, which are also called alkalis, as bases. Now, after understanding the Arrhenius concept of acids and bases, we must understand its limitations. So, let us point out the limitations of the Arrhenius concept. The first limitation, the most important limitation, is that we know that it is called existence of H plus ions. We know that in aqueous medium, H plus ions never exist freely. The moment they are formed, they are accepted by water and it forms this hydronium ion. And the acidic behavior which is shown by any medium is due to the presence of this hydronium ion and not the H plus ion, because it never exists freely. So, the acidic behavior of any medium is due to hydronium ion and it is not due to H plus ion. Whereas the Arrhenius concept says the acidic medium is acidic or behavior is acidic because of the presence of H plus ions. So that's very not matching with the what exactly is the truth is. The second limitation is that is the medium restriction. Arrhenius has given us a restriction that this concept can only be explained in the aqueous medium, or the neutralization of an acid with a base or vice versa can take place in aqueous medium. Whereas, let me show you an example. If ammonia gas is reacted with HCl gas and this results in the formation of ammonium chloride solid, this basically is a neutralization reaction which is taking place in aqueous medium, resulting in the formation of ammonium chloride. Now in this is acting as a base, this is acting as an acid. We feel that this is acting as an acid, this is acting as a base because this is going to give H plus to this one. But as per Arrhenius definition, this is not an Arrhenius acid, this is not an Arrhenius base. The reason is because the medium is the gaseous medium, it's not the aqueous medium. So the medium restriction is a limitation for the Arrhenius concept. The third and the most important limitation is that the species without H plus and OH minus ions cannot be classified as acids or bases. Like we all know phosphorus pentoxide, sulfur trioxide, manganese oxide, in which manganese is existing in the +7 state. All these are your acidic compounds which shows acidic behavior. But since they doesn't contains any hydrogen, they won't be releasing any H plus ions in the aqueous medium, so they cannot be classified as acidic. Similarly, ammonia, amines, these are not having any OH minus ions. So we cannot classify them as bases, but we all know they are very good bases. So these are again the problem areas, the limitation that those species which are not having H plus and OH minus ions cannot be classified as acid and bases according to this Arrhenius concept.